morning, everybody. I'm Erin Dul, and I'm from. You actually said my name, so that's great. I'm from NATE. The topic I wanted to present on today was the periodic table of hypothetical elements, which I developed as an approach to assessing inorganic nomenclature. So the challenge that I kind of faced very early on in one of my courses, I have a few entry level courses teaching inorganic nomenclature, and the answers are just very easy to Google. For example, if you ask a question like, "What's the chemical formula for carbonate?" or "What's the name of the compound CuSO4?" It takes the student 10 seconds to type it into Google, ammonium carbonate, and get the formula.
Erin,
Yeah.
Erin, if we can interrupt just for a second, can you please bring your microphone perhaps closer to your mouth because you are fading out periodically?
Thank you. Is it better now?
That sounds better. Yes.
Okay, I'm really sorry about that. Yeah. So if you type in CuSO4, copper 2 sulfate comes up immediately. So when I was thinking about this as I was developing my courses, I thought about three kind of different potential solutions to this problem. The first one being just keep my head in the sand about it, and let students just Google what they need to Google. I mean, there's a good argument for if a student can Google it that quickly anyways, do they really need to learn it? But I don't think that's the best approach to any of the outcomes in our courses. The next thing I thought of was doing a live video quiz with each student, so that we're doing something orally, but that would be too time consuming for me in my courses. And then the last solution that I talked about with a lot of my colleagues in the department was just timing the students doing the test, because if you give them 10 questions to do in 10 minutes, it's harder for them to Google, and it really shows what they know. But that's also not my favorite approach. I think it disadvantages some students over the others. So what I ended up coming up with was giving the students hypothetical elements to use in the nomenclature, something that they couldn't Google. So giving the students a name of a hypothetical element, a symbol, and other characteristics such as the group number or the ion charge or the group name. The student can then apply nomenclature rules in the same way that they would apply the rules if it was a real element. One very important thing that I noticed when I was doing this was that prior to giving this on a summative assessment, I really wanted to be fair to the students, so I gave them an opportunity to practice with this concept, and I think that's really important if you're going to implement this in your courses to also do this. So just a note. So an example of a question that I gave on a unit test was, so for the hypothetical element Grelin, the symbol GR, in group 6A of the periodic table, write the name for the following compounds. So the students would apply the nomenclature rules that I learned to this question. So group 6, so kind of an oxygen type element. So CGR2 would be carbon digrelide, for example. Does anybody want to type in the chat the answer for the next one? Maybe I'll give you. So this would just be sodium grelide. Thank you. Yeah, thank you, everybody. And the last one. Yeah, so copper 2 grelide. Perfect. So just applying the same nomenclature principles, and then also working from the name to the symbol as well. So the hypothetical element barium, symbol B1A, so sort of sodium potassium, of the periodic table and behaves like a group one metal. Write the chemical formula for the barium sulfide, barium sulfate, and the barium hydroxide heptahydrate. So if anybody wants to type those three into the chat. Sorry, I'm making you work here. Yeah, so, whoop. UV2S. The next one, UV2SO4. Last one. So BBOH, heptahydrate. So just to, a simple way to kind of, I think it's a good concept to be able to branch off of further. On my quiz results, most students performed as well or better on these questions that as the rest of the unit test I was giving them. There were a few exceptions. No students really complained about the setup of these questions. Nobody was emailing me saying I had no idea what you're talking about or that was really unfair. No complaints about these types of questions from the students. And I think this is a concept that can be extended a bit, depending on other types of questions, and thinking of things that are easily Googled. For example, if you wanted students to predict the reactions of products for a net ionic equation, you could incorporate a hypothetical element into a solubility table. For electrochemistry, you could incorporate a new element or reaction into a standard reduction half reaction table. And for bond polarity, you could sub in electronegativity values. So I think the advantages of this approach are that it's unable for students are unable to easily Google the answers to your quiz. It reinforces the concept and the rules, and it tests the student knowledge of other properties on the periodic table. For example, covalent versus ionic compounds, or the properties of the different groups. The disadvantage of using this approach is that I did need a bit of extra class time to prepare students for these types of questions. And I did always kind of worry that this was too abstract, something that was not right on the periodic table, might leave some students behind, although that didn't really seem to be the case. One huge disadvantage of this approach is that it doesn't prevent students from sharing information with each other during the test. It's something we just can't completely monitor. So that's something to keep in mind when using this approach. I noticed there's a note in the chat here that it also works well for predictive versions. Yes, I can definitely see how that would work. Well, you can make up your own unit. Yeah, so that is my short little presentation on this approach. I welcome any questions, comments, or thoughts on other applications of this sort of methodology in the breakout room. Thank you for